second last session. So tonight we're just going to go through those assignments, looking at the last three. So that was study units 6 to 11, and I just picked a few of those questions, and then tomorrow we'll do the last session. So if anybody have access to a mock exam that is under my modules on your UNISA profile, then if you can please download it and forward it to me, then we can look at some of those questions tomorrow, just to wrap it up. Yeah, and apparently it was all last year's or the years before's exam. So I'm also trying to get another exam paper, so that I can send that to you as well. So trying to get the last 2 years exam papers. That, thanks. Yeah, then I'll definitely send that on to you guys as well, and then we can tomorrow just look at that exam paper that was now a mock exam for you guys. Okay, so let's go into study unit 6 to 11, and just from your assignments, so this one is one that they love asking. I think we've had a few of these types in the prep up to now as well, and I will again just send you guys the whole presentation with a recording afterwards. Just want to see what's okay. So in this one, let me quickly get to our tables to see if I have it at hand or if I must go into let me go quickly to one of my files. Just want to open the tables again that we will work with. Okay, so the first thing they ask us in this one is that we need to check for, and you guys can also nearly check in your table. So first one they ask, consider this normal distribution and basically check between 0 and minus 2.4. So between 0 and minus 2.4. So basically we want that area. Yes, I see this hand. Oh, okay. So if we, yes, so quickly, we need to get that area. So um, we need to be between 0 and whatever. So let's just first see what minus 2,4 is. So the minus 2,4 there it is 0,0082. So this small area is 0,0082. So the area that we're looking for, and you can work that out in a few ways, but the easiest is to say that all area to the left must be 0.5, and we subtract that small area of 0,0082. Okay, and if we do that, our answer should be 0,4918 and not 0,0082. Okay, so let's just see what did we need to work out. Which one is incorrect? Okay, cool. So that is the incorrect one. So that is what we will go for. But let's just look at the other options as well. Between 0 and 1.8. Would be that area. So again, we can check what that small area is. And then we can again say 0.5 minus that small area. So let's see what is minus 1.8, 0,0359, 0,0359. So 0.5 minus 0.0359, that gives us 0,4641, which is correct. Now they want the next one. So you have all the information already for that third question, because now they want you to say, what is it between 1.8 and minus 2.4? So it is basically that component plus that component. So it is 0,4918 plus 4641, which is 0,9559. So we have it. Then they say if we need to work out what is the probability that Z is bigger than minus 2.4, is that then the same as 1 minus Z bigger than 2.4? And yes, it is, because that area will be exactly the same. And then most likely the same here. If you look at bigger than 1,8 is that area, smaller than minus 1,8 is that area, and that is also similar. So option E is also correct. Okay, so this one is one of those that they do ask. They've asked it a few times in assignments, in previous exam papers. So there are lots of them in this prep back as well. Definitely something that you will most likely get. Okay, then we go a bit into how to work out some of these Z numbers, and if you get a Z number, what to do, or need to get between two Z numbers. So here they tell us, given again that the Z is a standard normal distribution, what is the value of Z such that the area between minus Z and Z is 0,2358? This is an interesting one. Let's just again get a nice color here. So what's the probability? So they tell us sorry, just do that. Okay, so this is an interesting one. So let's quickly check. So basically what we're asking is, that is Z0. We've got a Z here, and we've got a minus Z here. The area between these two Z's are 0,2358. Okay, so basically we want to know what is that Z value. Okay, so again, what we do in this instance is we know that this is symmetry. So that area in the, let's call it reddish, and that area in green needs to be the same. So to get to that Z, we will need to say 0,2358 divided by 2, because that will be this component that we will need to add on. So that is 0.2358 divided by 2. So we've got in this area 0,1179, and in this area 0,1179. Okay, so now there's two ways to to go about and work it out. So I now have, say that was now the 0. So we have up until this point. We know that is 0.1179. So if I add the 0.5 to it, I get 0.6179. So now I can use the positive table to identify that Z. Again, where you need to be careful, if you have rounded off that 0.1179 to 2 decimals, there is an answer. If you've rounded off 0.6179 to 2 decimals, there is an answer. Okay, so we're going to the Z table, the positive. We're going to look up the 0.6179, and then we'll see what is the closest Z to that. Okay, so 0.6179. 0.6179. Okay, so there it is. So the Z is 0.3. So we know that that Z is 0.3. On the other side, it would have been negative 0.3. Okay, so option E is the right one. But yeah, first they give us the area between the two Z's. So we know that we're only looking for these two values. So we need to get it. Let me see if I can just, okay, it doesn't allow the pointer if I am not in presentation mode. So basically divide by 2 to get this small piece that we added on, add that to the 0.5 to get us to 0.6179. That we then go to the positive table to get our Z value that we need. Okay, so then let's go to the next one. Okay, so now it's a bit of theory in this one. And I just, so also please send me, while we are now chatting, the message that the lecturer shared with you guys around what you're allowed to do and not allowed to do, specifically with the notes that's in PDF and those kind of things. Okay, which one of the following statements is incorrect? Okay, the sampling distribution of that mean refers to the probability distribution of all possible values of the sample mean. Okay, so that is the sample mean. So A is correct. Then option B, if a distribution of the population is not known, the sampling distribution of X can be approximated by a normal distribution irrespective of the sample size. Okay, so if you look at this, this one is the incorrect one, because we always say that when the population distribution, if we don't know the standard deviation, we're not allowed to do certain things. So even imagine now if your distribution of a population is not known, then the less you can just assume that it is a normal distribution. So remember when we said that for a distribution to be close to a population, you need to know certain things about that sample. So is it likely to be like the population? And you can also just, with what they added about the sample size. So if you get 15 or 16 people that now needs to represent the population, and you also don't know specifics about that sample is just way too small to be representative of a distribution. So if it was a big sample, about 500, then you know that there's other things that do come into play that you can use, but with this emphasis also that it's irrespective of a sample size, that just makes it very difficult to say anything about the population. Okay, then I think we're gonna touch on option C with another question, but the larger the sample size, the smaller the standard error. And let's just check how we write that, the standard error. So remember, the standard error is your standard deviation divided by the square root of a sample. So the larger the sample, the larger this number that you're gonna divide by. So the larger the number you're gonna divide by, that means that this whole standard error will basically decrease. So if you had a sample size of 10, let's say your standard deviation was 10, and let's say your sample size was 16. Then it's easy to say, well, 10 divided by 4 will give you 2.5. So your standard deviation stays that, but now your sample increases to 100. Then suddenly you see that your standard error is coming down. So this is important one to look at, because they could ask the same question: what happens to your standard error if your standard deviation increases? Okay, so if your standard deviation increases, then your standard error will increase. So just be also in some of your questions that you already have, it might just be that they focus on one of the other variables in a question for the exam. Okay, so the same with confidence intervals when we get there, where it might be that an increase in, so let's look at this. So an increase here in sample size said that your standard error will decrease. So when we get to confidence intervals, your standard error have a direct impact on your margin. So if your standard error is basically decreasing, your margin will also decrease. So they could even do a combination between study unit 6, 7, and 8 around something like option 3. So just nearly look at how your sample size increase or decrease also have an effect on your confidence intervals. Um, then if you look at the fourth option, the sampling distribution of a proportion. Okay, so now we're nearly testing all of the options in study unit 6 and 7 can be approximated by a normal distribution. Okay, and the normal distribution, this is the mean. Remember, the mean is n times the pi or whatever the probability was, and then your variance is n times 1 minus that. So again, I think in one of the sessions, I showed you guys that how they sometimes have it normal distributed 0 and 1, where the 0 is the mean and the 1 is the variance, or it is also the variance is the standard deviation to a power of 2. So when we look at this, the normal distribution or approximate, then that is the mean, that is the variance. So again, just have that method of writing it down somewhere on a note as well. I think it is in your not, I don't think it's in the study guide, but I definitely know it is in your textbook. And then the last option, the larger the sample size, the narrower the sampling distribution of P, and that is basically what we just mentioned as well with your confidence interval. As your sample increases, your standard error decreases. As your standard error decreases, that will mean that the sampling will be narrower, or your confidence interval will also be narrower. So that is also correct. Okay, so let's go into the next one that was also in, I think it was assignment 3. So now we're going to look a bit at the formula, and from the formula need to work out one or two things. So a random sample of 120 is drawn. They tell us from a normal distributed population mean of 160. And then I assume that is, if I say normally distributed population with a mean of 160, the standard deviation of 50, that is the population standard deviation. And then they ask us, okay, first of standard error. So we don't need to go into the whole formula of this. We, in any case, don't have a x to work this out. So we could not, in any case, go to this. We just want to work out the standard error. So that is 50 divided by the square root of 120. Okay, so let's see 50 divided by square root of 100. Okay, let me just clear my calculator. That did not work. 50 divided by, and that then gives me, and if I wanted 2 decimals, so 4,56. And that is option 3. Okay, so there you can see that is the standard deviation. That is the mean. That is if you basically nearly read it wrong, because all the numbers are in there. And I think the 9,13 might be if you actually say 50 divided. No. Okay, so I thought it might be 50 divided by 160, but that will give you a smaller answer. Okay, so definitely not that. Yeah, so option C is the right one here, and we just needed to work out the standard error. So what you most likely will is that one of the standard errors of the population where the standard deviation is known, or standard deviation is unknown, or the proportion. So one of those 3, they will ask you a standard error. They're not going to do it for all 3 of them, but for one of them, they will ask you to work out the standard error. And it might be that you guys, again, when we quickly go through the mock exam tomorrow, it might be that between those, that one and all of these questions, we nearly have covered everything, that you can just see all the possible questions around that. Okay, so the next one. So basically very similar information. So now they say, consider normal distributed population with a mean of 190. So they just swap it around a bit. So the mean is 190. For standard deviation is 120. Sample size is N is 50. What is the probability that the sample mean is 220 at least? Okay, so at least 220 means that it must be 220 or more. So the Z must be 220 or more. Let's just, so it's 220 minus the 190 divided by 120 divided by the square root of 50. So when we draw it, that is always the 0 in the middle. It will be this component. Okay, so already we can see it is going to be something that's less than 0.5. So I automatically will say it's not that one. It's not that one. Sure. Chances that that small area is 0.4909. Probably not, but okay, at least we've eliminated 2. So let's see what this answer will be. So 220 minus 190, that gives us at the top 30, and then at the bottom 120 divided by the square root of 50, that is 16,9706. I just round it off to 4 decimals, but now my answer I will round it off to 2. So I get 1,77. Okay, so 1,77, and I want that piece. So I can again look at the negative table, 1,77. Is it that one? 0,0384. 0,0384. Or we can go to, I just want to show you also the positive table, 1,77. So there we have the 1,77 is 0,9616. So let's just say 0,9616. So there you have it. So if you made the mistake of reading the at least as at most or something like that, but then now we get to that small area is to say 1 minus the 0,9616. So if you wanted to use the positive table, that is how you would be able to work that out as well. Yes.
I'm following with you right now. So I would like to ask, how do we know which tables we need to use during the exams? From the phrases of the question, like which question tells us that you must use the cumulative standardized normal probability table, which one tells us to use a SAT table, which one tells us to use the chi-square table, which one tells us to use a Poisson table, which one tells us to do a binomial table.
Yeah, so you will, so the easiest nearly is for when it is the normal distributed populations, um, and you use the Z tables, you can use both the positive and the negative. Okay, so that for me is you need to nearly, when you, like we now did here, whichever one you were most comfortable with for the Z table. Um, so because you can see both of them you can use. What I normally, so with a binomial table, they will tell you in the question that you have a binomial distribution, or they will tell you that the outcome is something with the, let's say, the outcome happens or the outcome does not happen. So that's nearly the binomial distribution. The Poisson distribution is very similar to the binomial distribution, but what comes in extra with a binomial, with a Poisson distribution, is they will always bring in what's the likelihood in a certain time frame. So they will bring in minutes or days or months or years. So your Poisson is the one that has the time frame. Then with the normal distribution, the proportion one is always a Z. And again, then you need to nearly decide which one you the most comfortable with a positive or negative, because you can use both in any question. Um, then your standard deviation known, also use the Z. Standard deviation unknown is when you use your t-table, and your chi-square is when you actually work with two variables. So that is when the chi-square comes into place. Um, but most likely they will also, in the chi-square, tell you you're working with a chi-square distribution if they don't show you the crosstab table with the two variables. So I have a question in here that we also need to reference the chi-square. So I'll show you in that one as well. But then if I don't give you, so if I didn't give us the the normal or the standard deviation or telling us the mean, and we just get a test statistic, then we need to tell you you're using the T distribution, because when you need to get the degrees of freedom versus, um, so they need to give you a bit of information if they're not telling you directly you're working with a normal distribution that's distributed with a standard deviation and a mean. Okay, so I have a few of those questions in as well, where we nearly need to go and identify the table, but they tell us what to do then. Okay, so,
Thank you, sir.
and to that point, so when we see this question where we need to work out proportion, then we know it is a Z table if we need to work out the probability. Um, so let's see what they ask us, and then again we will identify which one is the easiest of the Z tables to use. But again, I'll show you both if we need to do that here. So in the question, they tell us the Ethics Institute published this report, the first in a series of annual surveys amongst a sample of 4962 South African adults. 42% thought it was not possible to get through everyday life without paying a bribe. Assume that the population proportion was 0.42, then they say, what is the probability that the sample proportion is at least, so again, like the previous one, at least, so the Z will be bigger, and again, it will be, remember that formula is for proportion. I hope I'm doing it correct now. I think that's divided by n and then the whole thing square root. Okay, so 0,426 minus 0,42, and that divided by 0,42 times 0,58 divided by this massive sample. So this is probably going to be something small. Okay, so 0,426, let me use my calculator that I'm not making a mistake with the decimal. So 0,426 minus 0,42 is 0,006. And at the bottom, we're going to divide by 0.42 times 0.58 divided by 4962. Sure, and that square root. Okay, so I get something like this, 0,007. So if I do that, let's hope it makes sense. The Z must be bigger than 0,86. Okay, so there is the Z value. So again, if that is 0, we've worked it out. Let's say to 0,86, and then we will need to get to this area that is bigger than 0,86. So for me, the easiest would be, because of symmetry, I know that the minus 0,86 will be the same size. So I will go to the negative table and look at minus 0,86. So if we do that, minus 0,86, 0,86, let's just check, 0,1949. So that is 0,1949. So again, if you wanted to use the positive table, you can do that, but then what we need to do is, where it is, what was it, 0,86, where it is 0,86, we need to remember 0,8051 is this area. So if we want to get to that green area, we needed to say 1 minus the 0,8051, and to get to the 0.1949. Again, you do see that they give 0.8051. So if you worked it out and you went to this area, so that is again where you guys will get maybe 1 or 2 marks out of 4 if you pick this. Okay, so like your assignments, if you make a mistake but you have actually nearly worked with the right numbers, then there is something for you to get to. Okay, so let's look at the next one. So let me just duplicate this slide and then crop it. Okay, so in this one, they tell us consider the 1 minus alpha confidence interval estimates of the population mean provided in the list of options below. The confidence interval estimates are based on the same alpha and the same standard deviation, but different sample sizes, where N1 is smaller than N2, smaller than N3, and the like. Which one of the following confidence estimates is computed based on N3? Okay, so this one is an interesting one. Um, so here you need to look at because we said the where was that question? Um, why is this now not? Okay, because we said as your sample increases, your standard error becomes smaller, meaning also that your confidence interval becomes narrower. Okay, so then your N3, because it's in the middle, it will basically be the third biggest confidence interval. So let's basically, for each one, we need to subtract the two numbers and see which one is the middle highest number. So 59.78 minus 40.22. So the first one is 19.56, then 56.91 minus 43.09. That is 13.82. Then 54.89 minus 45.11, 9.78, 53.46 minus 46.54, 6.92, and then 52.44 minus 47.56, 4.88. So the number in the middle of all those is 9,78. So our answer would be option C. Okay, this one, there's no, you could now try and use numbers, but the easiest is to say we're looking for N3. N3 is the one in the middle. Um, so another way to look at it is which of your lowest confidence is the smallest or the third smallest, or your upper confidence is the first smallest. So um, there are a few ways to nearly identify it. So if they have said um, you're looking for N2, so then again you will look at N1, it's smaller than N2, so that means your second smallest number, so um, that would have been N2, that would have been N1, N4, and N5. Okay, in this instance, um, it is by fluke that it is biggest confidence interval margin to smallest. It not always, it can be shuffled and mixed in the numbers. So this one just by the way is from biggest to smallest, but it's not always like that. So don't just say, okay, because that's in the middle, it's the one in the middle. Okay, so this one was by accident that it was ranked from biggest to smallest. Okay, I see it was also in the mock, so I will share that one then with you guys tomorrow night as well. Yes, there's a question.
So it was my question is pertaining to the previous one because I had a
Yes.
similar one like that where I was doing a mock. So I actually got confused because while I was subtracting the things, I chose the one that was the biggest one, and then it chose the one. They chose the answer that I chose. It was the smallest one. It actually marked me wrong for that.
Okay,
Actually, the
so yeah, so that's important nearly to see what they ask, and I think also important that, and it will be interesting if the mock exam, because there's other things that they can also look at. So with the ends, they can do that because we know that what's happening here with the n, that we nearly need to see if that n is 10 or 20 or 30 or 40 or 50, what will happen to that confidence interval. So as that becomes bigger, the number that we divide by becomes bigger, so the confidence interval becomes smaller. What they can also do is just be now careful that they don't do something like this in the exam, where we now had in the mock exam and in your questions the n, but just now be careful that in the exam they don't tell you that the confidence intervals are based on the same alpha and sample size, but your standard deviations are different. Okay, so just be very careful now with the exam that they don't change the n to standard deviation, because now as your standard deviation increase, your confidence interval will become bigger. So just be careful. Here it was as n increases, your standard deviation will become narrower. If we look at the standard deviation, as that increase, your confidence interval will become larger. Okay, so yeah, I will tomorrow look at a few of the mock exams, and then we will look at that one in the mock exam. Okay, so let's look now at um, one where we basically need to work out the confidence interval. So again, important that that we need to first nearly identify population standard deviation, known or unknown, that we know if we need to work with a Z or no. So simple random sample of 16 from a population with standard deviation. Okay, so we know it's a population standard deviation, so we know we can work with a Z. So if we can work with a Z, we can work with this formula. Okay, so then we know a few other things. We know that 600. So what I normally do, but I've seen that they have not done this lately, but what I will do is I'll just check quickly. So if my mean is 600, that means that 600 will be in the middle. So your upper limit will be more than 600. Your lower limit will be less than 600. So I normally just do a quick, okay, less, more, less, more, less, more, less, more, less, and more. So through that, okay, could not eliminate, but just wanted to make sure that there is not something that one of these we can already eliminate. Okay, then standard deviation is known. So they tell us we're working with a 95% confidence interval. 95% is 1,96. So again, we don't need to even go to the Z table. We need to, from that table in your study guide, we can already identify when Z or when the confidence interval is 95%, we can work with 1,96. Then we have our standard deviation of 120 divided by the sample size. So now we can work this out. So 120 divided by square root of 60. So it's 120 divided by 4 gives us 30. 30 times 1.96. That is plus minus 58,8. So the top one will be 658.8. The 658.8. And then if we subtract it, we get the lower one as well. Okay, so here we've seen because population standard deviation is known, we can work with a Z, then they must tell you what the confidence interval is. It is 95%. So because of that, we can work with 1,96. And then the most likely last two, wait, we've done this. I now duplicated that already. Okay, so let's, and just want to see, okay, I've duplicated also, so let's just crop it out, that we first do this one so that we can see what we work with, and this one when we start looking at hypothesis testing. Okay, so let's look at this one. Let's see what they're asking, so that we again can decide, do we use a Z, do we use a T? Um, so, okay, so this is proportion. So if we have proportion, it's always a Z. So in a survey involving 160 data scientists, this one looks so familiar. 96 reported that they work remotely. What is the lower confidence, or what is the lower limit of a 95% confidence interval estimate of a proportion? Okay, so basically remember, the proportion is the 96 divided by 160. We want to get the lower one, so we're only going to subtract. Then it is the Z, but again, we're working with 95%. So we can automatically say 1,96, and then it is multiplied by, remember, the standard error component of the the proportion. Sorry therefore. So let me just get what 96 divided by 160 is. We can, okay, so 0.6, and it is 1 minus 0.6, which is 0.4, divided by n, which is 160, and then the square root of that. Okay, so 0.6 minus, so now nearly to that point is 0.6 minus will be then less than 0.6. So it's not C, it's not D. So we basically have A, B, or E that can be our answer, because we know that 0.6 is in the middle. We're looking for this lower confidence, so it must be smaller than 0.6. So already we can basically eliminate two of those answers. Okay, so let's see, 0.6 times 0.4 divided by 160. We take the square root of that, and that will be 0.038. If we multiply that by 1.96, we get it as minus, or what we need to subtract is 0.07591. Okay, so if I subtract that, I get my answer as 0.5241, and I need to get to 3 decimals, so that will be equal to 0.524. And if we then look at the answer, it is option B. Okay, so this one very specifically, we needed to work out the proportion. of a confidence interval, or then specifically the lower limit of a confidence interval of proportion, so we know we can use the Z. They said to us 95% confidence interval, so that means your Z is 1,96, and then we just subtract the twos. Also check if it was plus, that would have been your answer. So they also nearly have an answer for you if you worked out the top limit. So just again, be very careful in what they say, because they told us we're looking at the lower limit. Okay, then we go into hypothesis testing. And we can look, they say in a sample of 36, again, population standard deviation. So we know that in any case, if we need to do anything, we are working with a Z, and then they give us options. But first thing, let's just look at, so here we need to work out a T-stat. So that we will need to work out with this formula. So I'm rather gonna wait and see if I can maybe cancel something else out. Okay, then we get a p-value, so those two are linked. So let's then go to the next one. At 5% level of significance, do not reject. At a 10% level of significance, do not reject. So it's mostly likely that one of those two will be the correct one. So because, and most likely at 5, because if we reject or not reject at 10, we will also not reject at 5. And then a two-tailed t-test is applicable. Okay, we want the correct one. Two-tail is right, but because population standard deviation is known, it's not a t-test, it's a z-test. Okay, so I just saw two-tail, and that was nearly where my head was going, but that is incorrect because it's a z-test and not a t. Okay, so unfortunately then we need to work out the t-stat. So in the sample 36, the sample mean is 75. So 75 minus 70 divided by standard deviation of 16 over 36. So let's see what that, 75 minus 70 is 5. 16 divided by 6 basically is 2,6667. So if we say 5 divided by that, we get 1,875. Okay, so T-stat is wrong. It is 1,875, not 1,96. Okay, so let's see then if we have 1,875 what is this value? So again, I will go to negative table to get that small area. So 1,875, 1,8. So let's just use a different color. 1,8, then 1,875. So we need to be between those two because it's 1,87, 1,88. So we need to be in between those two. So 0.307 plus 0.0301. If we divide that by 2, we get 0,0304. 0,0304. Okay, so they used 0,0301 because they rounded it off to 1,88. So let's quickly see. They used the 0,0301. So we can do that as well. Okay, so the p-value is 0,0301. Also actually incorrect because we're working with a two-tail. We've got a 0,01, sorry, a 0,0301 here as well because it is two-tail. So our p-value is actually 0,0602. Okay, so our p-value is not just that small area because we're actually working with a two-tail. Remember, it is both the left tail and the right tail that we need to add together. So it's 0,0602. So now we can see 0,0602 is bigger than 0,05. That one. And it's smaller than 0,10. Okay, so we are going to, at the 5% level, do not reject, but at the 10% level, because it is smaller, we will actually reject it. So option D is also the incorrect one. So the correct answer that we're looking for is option 5, option C, because it is the 5%. And just that is where the importance of a p-value, because if you set 0,03 is the p-value, then that would have been smaller than 0,05, and it would have been smaller than 0,1. So then you would have said both of them are wrong and option B is correct. So very important, nearly again, identify that it's two-tail, but it's a two-tail with a Z test. Then when we work out that p-value, it needs to be two-tail. So that's why the p-value becomes 0,0602 because it is two-tail. Okay, so that was nearly the way to that they wanted to catch us out, because very easy then to make the mistake by getting the 0,0301 as your p-value, but remember it is two-tail. Okay, then we've got another one here, and this one I think was in the the mock assignment as well. So some very similar one to the mock assignment that you guys had on hypothesis testing, that they then brought into the assignment for on hypothesis testing. Um, so let's first see what they say. So they talk about the information, but let's, yeah, in B, compared to this example in the lecture note, okay, so don't know what was in there. Assume here that the population standard deviation is unknown. Okay, so that automatically tells me that we're working with a T. Okay, so T distribution. And then let's just see what else. So consider the Glow toothpaste quality assurance example. The production line for Glow toothpaste is designed to fill tubes with a mean weight of 180. Periodically, a sample of 30 tubes will be selected in order to check the filling process. Quality assurance procedures call for continuation of the filling process if a sample results are inconsistent with the assumption that the mean filling weight for the population of toothpaste tubes is 180 grams. Suppose that a sample of 30 provides a sample mean of 180 and a sample standard deviation of 6 grams. Okay, so consistent with the assumption that the mean filling weight for the population is 180. Okay, so did I somewhere missed if where they say, because at the moment for me it is the null hypothesis is equal and the alternative is not equal to. They did not tell us it needs to be bigger or it needs to be smaller. They're just telling us that if it is not 180, so let me just read it quickly again to see. So consider that the production line for globe is 4 tubes of that will be selected. Quality assurance procedures call for the continuation of the sample's results are consistent with the assumption that the mean filling weight for the population of toothpaste is 180. Okay, so they tell us that it's 180 is the null hypothesis, and then the alternative is that it is not 180. Okay, so then we can work out the T, but in Z, in hypothesis testing, how we work out the T is similar to how we will work out the Z. The only difference comes in when we then need to test it, we will need to use the T table. Okay, so just important, we do exactly the same. So the only thing is that now it's the sample standard deviation and not the population, but all the other stuff is exactly the same. So suppose the sample mean is 183 minus 180, then the sample standard deviation was 6, and your sample size was 50. Okay, so then we work that out. So 183 minus 180 is 3, and we divide that by 6 divided by the square root of 50. So that is now going to give us some decimals. So basically we're looking for a t of 2,74. Okay, so that is going to be our test. Do they say, so here they say all the 3% and 1% and all those kind of things. So let's look at the T with degrees of freedom of 29. And let's just go to that table and then scroll across. So T was equal to 29. Okay, so we will be looking at those numbers. Okay, so let's just cancel. Where is the, it's not to undo, so let me just, no, how do I get rid of that? That's what I hate about this one. Okay, but we are basically working with these numbers. Okay, so we got 2,74. So we got 2,74. So you could see that 2,74 is between those two numbers, so between 0,1 and 0,005. So smaller than, let's quickly just draw that. So there is the 2,74. It's very difficult to actually get the p-value of that. They want the correct one. Okay, so sure, how do we get the p-value if we have this? So I just know it is in between those two numbers. So if you went and checked the Z table, that would have been your p-value. So let's just check 2,74. So negative 2,74, 2,74 was 0,0031, 0,0031. If it was one tail, we're working with a two tails, so it would have been 0,062, but that is for Z. We're working with a T. Okay, so then let's look at the 3% level of significance. We do not reject the null hypothesis. Okay, if I look at where that is lying again, it is lying between those two numbers. So 0,03 is somewhere here. So that is not at the 1% level, level of significance. We reject the null hypothesis. So let's just look at the 1%. I think that was on that one. So no, it's between those two. So it's not at the 1%. Okay, so where the p-value is bigger than 0,05 and smaller than 0,01, bigger than, okay, so that is where I want it. So I would have said that one. Why do I say? Okay, so again, it shows how they can catch you out. And so that is for the one tail. Okay, so look again at that. Okay, here's a lot of, I will again share a cleaner one with you guys. So there's the one tail. We're working with a two tail. So then I wanted to say that one is correct, but that's for one tail. So we need to multiply all of these with 2. So 0,05 times 2 gives you 0,01. 0,01 times 2 gives you 0,02. Okay, so this one was really a tricky one because there was an answer for you. If you worked with the Z, here was the answer correct. If you worked with a T-tail or T distribution, but that was for one tail, and we working with a two tail. So the right one that we're looking for is basically the one tail times 2. Okay, so this was really a tricky one. So I will just check again if I have another one like this that we can do tomorrow. Okay, so again to the previous question of some of how to use some of the tables. So here with chi-square, if they say to us this in numbers, they need to tell us we're working with a chi-square. Else they need to give us a table and say what we're working with. Else they need to tell us chi-square. Okay, so chi-square with contingency table 6 rows. So remember row minus 1. So to get the degrees of freedom, so 6 minus 1, and then column minus 1 is 3 minus 1. So it's 5 times 2, which will give us 10. Okay. So if you set 6 times 3, luckily there wasn't 18. If you set 6 plus 3, luckily there is not a 9. If you set 6 minus 3, also not a 3. So nearly any other ones is really not available for you. Okay, so that is how we would have done just to get the chi-square. So then what can be, and I think it was, so let me just, okay, so the next question here was then linked to going to the table. So let me just see if I can look at the crop and then just quickly duplicate so that we need to go to, sorry, I thought I did duplicate it. Okay, duplicate. So that we can look at this as well. Okay, so I see this was in the mock as well. Okay, so let's now just crop and move it up. Okay, so that we can just quickly go and look at how we need to use the chi-square. So again, here they tell us, now consider contingency table, 5 rows, 2 columns, but they still need to tell you what you are testing for. So that would have been then 5 minus 1, 2 minus 1. So the degrees of freedom would have been 4 times 1 is 4, and the level of significance is 1%. So let's go to the chi-square. Okay, so here we are chi-square. Degrees of freedom is 4. The level of significance is 1%. 1% is 0.1. So then what we're looking for is 13.277. 13.277. Okay, let's just, for interest's sake, always want to see what is the other options that it might have been, so that we can just see how their brain work. 18.307. Okay, there's nothing really around here. That's 18.307. 18.549. Okay, also not really. Okay, there's 18 point. Okay, so if you used the previous question, the 10 and something, there was for 18 point. There's the 18.549. Okay, so I don't know how you got there. With degrees of freedom 12. So again, then 34.805. So if you set on the previous question 6 times 3 for your degrees of freedom, and then at 24,996. So let's quickly see. Okay, no, there's not a 24 comma. There. So if you set 5 times 3 or somehow to get to the 15. Okay, so there are random numbers out of the table, but we basically, degrees of freedom are 4, level of significance is 1%. So we get to the 13.277. Okay, so let's see, the next one is on that you need to look at regression. Again, one of the questions was around Excel, so you are allowed to use Excel, but remember it needs to be an empty spreadsheet. So unfortunately, no formulas in it. So you can also use, okay, so also exactly like this in the mock exam. Okay, so that again tells you there is certain things that they love to ask. So let me just put this down first, the excess. I will then make it bigger. So again, the if there's any 1510 guys on the call or listening to this later, you guys are not allowed to use Excel. So they will not ask a question like this where you actually need to use Excel to work it out, because you will not need to work something like this out if you don't have certain things, because um, unless it is easy things like the sum of x. So if the sum of x was the wrong one, um, but again, you can see, so let me just, so the sum of x is 86, so that is correct. We're looking for the incorrect one. Okay, so there we needed to work out something. There we needed to work out something. Remember B0 and B1. So the one is the slope. So we're putting in the y values first. We're putting in the x values second. Okay, so let's quickly work out the intercept one. Again, y values first, x values second. And where you can see, so B1, B0, B1 is also the slope, B0 is also the intercept. So with this one, yeah, so you need to, I will send you the Casio FX82 manual so that you can see how to do that. I've got the HP, and on mine, what is important is nearly the order. So I need, in the HP, I know I need to put in my XY, the first one, then X2, Y2, and then it has the buttons to work out B0, B1, and those things. So I will send you guys on the WhatsApp group. I will send you the Casio FX and list some of your other Casios and shops that you also have, but I can just see which ones we have a manual for. Um, in this study guide, let's quickly check. So we now know that that one is wrong. So let's just quickly check in the study guide which calculators they have at the back, because I know there is. So as that one downloads, let's quickly check here. Just want to check. I know they. Okay, I might be in the wrong study guide component, but let's quickly. Yeah, so this was the extra questions. Let me just see if I've got the study guide at hand, else I will download it. But I know at the back of the study guide there was one or two calculators, but I will just check on so you guys can put your calculators down with the different brands, and I will just check if I have manuals for you that I can share. Okay, then the last one. So the last one I thought was also an interesting one. It was in your mock assignment. Then it was also in your assignment that you needed to do. And let's look at the question. So consider the observed and predicted readings, the speed of this primary school, use the given information to calculate the sum squares due to regression. Okay, so the first thing that we need to know is what is the sum square of regression. Then if we have that, what we need to do and what it actually is we need to sum the difference of that minus that one. So nearly, how do I write it? I minus the hat of that, or the predicted. So again, this is not, and I think we need to square it as well. So again, not easy to just or quick to do it with your on a rough piece of paper, because you would need to say that minus that to the power of 2 plus that minus that. So this again is something that, and I will afterwards just share this formula sheet. I will also just see if, and let's call it at, if I have, I know I used to have a file that had all the things in, so I will just check if I have that still and share that with you. But let's see, 153, 85, 72, 97, 121, 93, 62, 104, 103, 94. So that was all wise. Then 83.71, 72.4, 95.01, 117.61, 83.71, 72.4, 95.01, 128.91, 106.31. Okay, so what I would do first and let's just make it bigger, is to say what's the difference in the two. So that minus that, not minus 1, minus that. Okay, so if we take the sum of that, we get something that should be very close to 0. So because there's numbers rounded off, but if you take the sum of it, it should be equal to 0. But here we want to get the square root. If we do that for all, and we take the sum of that, okay, so did I now work it out incorrectly? Okay, so I worked it out incorrectly. So let me just check what am I missing in that formula. That is now interesting. What am I missing? That was study unit 11. So let me just quickly open it. So again, remember you guys, it is open book. So please don't, like I now did, guess what the formula is. We have the study. So let's just, okay, there it. Okay, I'm just opening all the ones that, okay, so we were looking at some, okay, the SSR. SSR, okay, so there's the, so I worked out the SSE. Huh. Okay, so we're looking for the SSR. Okay, so that is totally a different formula. Okay, so I actually worked out some of the SSE with one of those. So we need to get the SSR. So yeah, please don't, like I now did, just work out a formula that you think it is correct. We have it in the study guide or in the notes. So let's just make 100% sure. We want to work with the SSR. Okay, so okay, so we need, let's just see if we've got all that information. Got, why do we have, or did I not copy? And let's just see if there's another one, because I don't have enough information there to work it out. Let's just see if there's another formula for that. Okay, not in this. I think there needs to be another formula for that one. So if any of you guys have picked up the formula somewhere, please let me know. But else, let's quickly go through. I know there was a formula that was different. Okay, so still not. Still not SSR. See, that's a SSE. Oh, is it exactly the same? Okay, observe value and yeah, so that's a SSE. E. So can it be just quickly put that one there. But that's still not one that we need. Cool. Thank you. Okay. But see there you have the X and you have the two different numbers. So I'm just, okay, so here it is exactly the same. Y minus that to the power of 2 and the sum of that. Okay, that's what I did. That minus that to the power of 2. Okay, so that is what we did. So why is it not working? So let's just check if I used the right numbers. 153, that, so minus, and then square root. 85, that is 72, that's right, right, right. Hmm. And then we said, that is right, that is right. All of that is correct. And then that's the sum of it. I will just check what did I, and I'll let you guys know, but that, so that is what we needed to do. If I look at this, reading speed predicted, reading speed predicted, yeah, okay. I'll just check what happened in this one. And maybe there's something in one of the mock exams, but I'll just go and just make 100% sure why this is not aligned, because they have said to us the SSR and the SSE are similar. So let me just go back and check, and then check if my formula, because that looks right, to the power of 2, we've done that. So I just want to check if my Excel again is doing it correctly as well. I know last time I had issues, so let me just make 100% sure that everything is correct there. Okay, so that was the last one. But again, you guys, or they will not ask you really these last two. I will send some of the um the guides to use your calculators, because what we have seen in previous exams is that they will nearly the things that you can work out quicker. So